Yeah, welcome everyone. My name is Florian Grandmontagne. Actually, I visited, it was virtually, some of the Munich++ events before, and I have to say, always when I took the time to visit these events, I was quite happy to do so. So the content was always great, the discussions were great, so many thanks for the organizers of MUC++ to enable that, so thanks a lot. Let me start to introduce a bit Rohde Schwarz. You see the spectrum of things Rohde Schwarz does. But today I want to tell you why I work for Rohde Schwarz personally, so what's motivating me. And I work at Rohde Schwarz since a couple of years. What I like about working here is the passion for innovation we have here and going really to boundaries where things are possible and even push them a bit. So for me, it's a very nice experience to participate in this. And the other thing is Rohde Schwarz exists since 90 years now. And still today, I think the working environment here is in such a good shape that you can really do it. And I feel good investing my time here. So in case, you like what you see here, we do a lot of C++ and you're looking for a job. I'm sure we have jobs open, so you can apply for it. And we have different locations, so not only Munich, but you can look it up. I studied electronic engineering with a focus to communication. And when I'm not sitting in front of several monitors, typing in some nice code, I like to do some sport like bouldering. And I have another hobby related to 3D printing. This is a model I designed. You can find it in the internet. I'll try to let it fly, so mind your heads. Okay. Oh, it's gone. We need a ladder. So still working. And I have a family I like to spend time with. It's gone. Awesome idea, yeah, let's do it. I started at Rohde Schwarz 19 years ago, so quite some time. I started in the area of VHDL programming, so programming stuff on FPGAs, a lot of things working parallel. It was quite fun doing so, and I moved more and more into the direction of C++ in embedded systems and also on the PC side. And in this context, I also got into contact with clean coding. And nowadays, I participating in developing this nice small-sized receivers. So you plug an antenna onto it, and then you are able to receive nice radio signals in the air. And by that, you can verify mobile networks and verify the quality. So telecom and other providers, they use that to assure that our mobiles are actually working everywhere. So that's the idea behind it. C++ still, and clean code. If you look how we work today, of course we work in teams. All members in the teams, they have their abilities, and just by combining these abilities, we are able to make the journey to create awesome stuff. Where our projects might start out rather small, maybe, eventually they tend to grow and get more adult. And hopefully, they will get maybe more positive vibes than the small guy implies. And maintainability and speed is, of course, always a topic we care about, isn't it? So that's why we use, for example, C++. But with complexity of software systems, we face different kind of issues. So the teams grow, we have different teams which have to work together. How communication flows can be tricky. To speak the same language can be a hurdle. Implementing new features in an existing software system can be tricky. You have old stuff your customer still wants to use. You have new stuff you want to provide. Bringing these two together can be a tricky thing. And at the end, it's about how fast can we do that. So how fast is our software in this case, and how fast can we implement? And this can be tricky as well. So the question is, I want to raise here is, how can we keep software systems in a good shape. And one approach here can be decoupling by message-based software systems. So let's have a look how such kind of a decoupling can look like. And for that, I would start with the example I just explained. So let's say we have a small receiver we want to use, or our customer wants to verify his mobile network. Therefore, he needs an UI enabling him to doing this job, to verify how good his network is at certain positions. The UI might be graphical or some web interface. And because the position where we do the measurement is important, we will most likely need kind of a position source, so a GPS module, which delivers us this position. And what we need further is, of course, kind of a module which is doing the actual measurement. So let's say we want to verify 5G mobile networks. We'll most likely need a module which is able to do this. And to enable this, we need to receive the data which is in the air. So we have a small-sized receiver somewhere, which is receiving the radio frequencies in the air, and is able to convert it into something a computer can understand, so IQ samples, and this can be processed. And at the end, our customer is able to drive around and verify how good his network is at different positions. So as you can see, we have defined 4 core development modules, and the whole system is almost entirely driven by messages now. So you can imagine if the user starts the UI will send a message to the GPS module, commanding it to deliver, let's say, the position 10 times a second. So the message is sent to the GPS module, and the GPS module will start configuring itself, and hopefully, in the good case, it will deliver back as messages the position 10 times a second. So the complete system is driven by messages, and messages are the decoupling factor here. So of course you are right if you think about the UI has the user interfacing to your system, that's true. But usually, and in many places, you will have just messages. And the same is the case if you think about how the 5G module is driven. So the UI will send a message to the 5G module requesting to start measurements, delivering, I don't know, 20 measurements per second, for example. The 5G module will receive this message, will set up a configuration, and while doing so, it will command the IQ source to do specific measurements. So measure at a certain time, for a certain length, at a certain frequency, with a certain bandwidth, everything what is required to get the job done. And in the good case, the messages will flow back the chain till the user can see what's happening. So the interface which is defined between the modules are the messages in most of the cases. And what you see here is kind of the logical message flow. So in practice, in our case, it looks like that. So we have, of course, a kind of a message broker. In our case, it's called Kernel. Let's call it Kernel. You still see our 4 core modules in place. They all run in different threads, so quite for themselves. The kernel takes care about how the messages are routed. And actually, you can imagine that messages can actually flow from any module to any module. What you see here on the left-hand side is just the way you utilize it. But in general, you can do it whatever you want in this environment. And the kernel has more functionality even. You can request the kernel to load modules. So if the UI is starting up, it will request the kernel to load the GPS module and the 5G module. And the kernel will try to do that. And in case of success, it will return it worked. So you can imagine that is a rather small example of how such kind of a software system can look like. And without changing a single line of code, you now can split up your software system into 2 processes. Why is this possible? Because the messages didn't change. The whole system is running on messages, and it doesn't matter where it runs. The kernel will take care about the routing, and it will care about where the module is loaded. But you don't have to change a single line of code in your project. And you can even go one step further and split your system to run on different computers. Still the same topic. The kernel will take care of your routing and loading the modules. So, and by that, you can imagine how nicely such kind of a system can grow. You can start out a small project in one process. It will grow over time. It will get bigger and more adult. And then, at a certain point in time, you will decide, okay, I would rather prefer to run it in different processes. And you can simply do it, and you don't have to change your modules for it. The messages are defined. They are binary exactly the same. If you would have an endiness conversion required, the system can take care of it, and therefore your modules will simply run. So let's take a look to this core feature of messages. And for defining messages, we have a central database. So we have a place where each developer has access to, can see all messages defined, can see the relation which module is using and utilizing which messages, and has, of course, a version history integrated. And you can imagine that this is a very good fundamental base to actually discuss stuff. Yeah, you can have a look to one module. You can think about how it is commanded, what it will return, and this helps a lot to make and provide a very good communication in your team, actually. And furthermore, the databases and the interface is written in such a way that that it takes care quite heavily, or as hard as it can, to keep things backward compatible. So that you can extend, for example, messages in a way that they stay compatible. I will skip that, how the messages are actually used. A last point I want to point out here is that you can record your messages, and you can, by that, replay it. That is quite a nice feature. First of all, if you develop a module or participate in developing one, you can easily imagine that it's awesome that you can create an input vector of messages, run it through your module, and you verify the output messages your module is creating. And you can do it in a system where you have, I don't know, 50 modules. You take one out you're working on, and you can do this very good, in a very good way. And now imagine you deliver your system into the world, and then at the other side of the world, something happens you have never seen before on your desk in your lab. Now, if it's reproducible, and in many cases it is reproducible, you can request to record it for maybe just the modules which you think has to be approved, get it on your desk, and replay it as fast as your computer can calculate. And that helps a lot to actually improve your software. So to sum up, well, the system, I would say it's very, very nice growing. You can start out with a simple single process. You can have multiple processes. You can run it on multiple PCs. You can just configure it the way you need it. Adding modules, extending modules, or removing is not such kind of a big deal. They are just driven by messages, and if you take care about that, you can do a lot of stuff quite easily. You only have to deliver or build the modules you actually changed. If you have a system of 50 modules and you work on 4 of them, you just build these 4 modules. And of course, you have to test it in the complete system, yeah, but you don't have to compile everything in this case. Why? Because everything is message-driven. The messages didn't change. And you have this feature that the messages are actually defined in a central place, and your whole team can see what your software is about. It supports you in during development. Well, you see you can use it quite well to test single modules, as well as to get in real-world issues and work on it. And think about how handy it is that you can take a software system with a lot of modules where you have somewhere memory issues, and you can just spread all modules to run in separate processes. That might help a lot to figure out which module has problems. So, and the whole system was written for high performance, nevertheless. So it takes care that memory is copied just when it's really required and not more often. By thread and process and PC separation, you are quite flexible about how you can use it. In our environment, we use this kind of a system since 30 years, when GSM was rolled out, more or less. And we use it still today. And you can imagine that it grew immensely. So there are a lot of modules nowadays in place, and it is really, it just grow with our needs, like the networks outside grow. So maybe you can think about the projects you are working in and think about how beneficial such kind of a feature set would be. Thanks a lot for your attention.